Hi everyone, it's Mr. Neff. Let's look at the adding and subtracting vectors assignment. So on number 22, it says, referring to this picture, is the magnitude of a plus d greater than, less than, or equal to the magnitude of a plus e? So what you want to do is you want to add those head to tail, and that's kind of easy for me to do here. All I have to do is just trace over these things. So this is going to be my vector A. I'm actually going to do it twice. D, I will make in red like they did. And E is like so. Now you can see that D and E are the same size. They're just opposite directions. So here's a nice picture of A plus E. And here's a nice picture of A plus D. Thing about it is, even though D and E were the same size, the direction makes a big difference. So look at this really big vector relatively that you get from adding A and D. This black one is A plus D, versus when you add A plus E. See how E cancels A out a good bit. E, we would say, has a negative component, whereas D did not. So this is A plus E, and it's just this little baby. So it looks like A plus D is much greater than A plus E. 23, sort of like that last one. Is the magnitude of B minus C greater than, less than, or equal to B minus F? All right, so here's a B and another B. Now I want to subtract C and subtract F from those B's. So rather than just trace C like this, that's not going to work for me. What I need to have a negative C, because adding a negative C is the same as subtracting a C. Same thing with the F. So I'm going to do an F that's the opposite way, like that. All right, so now B minus C, here's a B, and here is negative C. So this is B plus negative C, B plus negative C, also known as B minus C. And there it is right there, B minus C. Sort of like that, I'm going to take a B and I'm going to take a minus F. And so this is something similar to what was happening in the last one is happening now. Here's B, here's minus F, and you can see that B and negative F, they're not parallel, but they're also not canceling each other out. Versus, see, B is straight up, and C has a component, negative C anyway, has a component that goes down and a component that goes over. Well, right there, you're getting a lot of canceling. And consequently, you can see that B minus C is very small compared to B minus F. So B minus C is less than. So in 24, I'm supposed to use a sketch to show that two vectors of unequal magnitude cannot add to 0. This problem's a little bit flawed because I'd have to draw sketches forever to show that it can't, and I still would never have every case covered. But I can show you one or two here that can show that. So if I have two vectors of unequal magnitude, maybe there and there, they're unequal magnitude because they're two different lengths. Yeah, of course they don't add up to 0, right? No. Now, thing is, if they were pointing backwards, maybe they would have a chance. And so what about if I took those same two unequal lengths and I went like this? Well, that's closer to 0, but that still isn't 0. You say, come on, man, why don't you just draw them completely opposite? Okay, well, there. And I still don't have 0. You say, well, why don't you just draw it exactly the same way back? Well, if I did that's exactly what they told me not to do. They said they have to be unequal length. So even though this does add up to 0, and that's the only way I could do it, it violates the problem. So I can't do it. So you can see that I'm never going to be able to get 2 adding up to 0. On the other hand, if I had 3, I could easily get it. I could go bam, I could go bam, I could go bam, and see, I got nowhere to draw the resultant to. I got 0. So can't do it with 2, but can do it with 3.